During an outage, engineers spend hours manually correlating log timestamps across 3 or 4 services to reconstruct what happened to a failing request. Incident timelines are guesses, and postmortems are based on partial information. The same failure mode recurs because the root cause was never fully understood. Here's exactly why. Let's start with the basics of monitoring and observability. Welcome to TheCodeForge. Before we dig into that production issue, let's cover monitoring observability intro. Monitoring is the practice of collecting predefined metrics, like CPU, memory, request rate, and alerting when they cross thresholds. It tells you that something is wrong, but not why. Observability is a system property that lets you infer internal state from external outputs without shipping new code. It answers why it broke and lets you explore unknown unknowns. The 3 pillars, metrics, logs, and traces, are the raw materials of observability. Metrics give you aggregated signals, logs give you discrete events, and traces give you end-to-end causality. The real power comes from correlating them with a shared trace ID. The trace ID in your logs is the most important field you can add. It is the hyperlink between a log line and the full request journey. Without it, cross-service debugging during an incident is archaeological work. Let's look at a real code example that instruments all 3 pillars in a single Java method. This pattern is from the article and shows how to emit metrics, structured logs, and traces together. This code uses micrometer for metrics and OpenTelemetry for tracing. The trace ID is injected into MDC, so every log line includes it. The timer wraps the entire business operation, and counters are tagged by status for separate success-failure tracking. Prometheus uses a pull model. It scrapes your application's metrics endpoint at a configured interval. This protects your monitoring infrastructure from a misbehaving app that might flood a push-based system. Here's a typical Prometheus scrape configuration. Notice the metrics path for Spring Boot is actuator Prometheus, not metrics. Relabel configs normalize instance labels to prevent cardinality drift. This configuration sets up scraping for the Forge API service with a 5-second interval. The relabel config normalizes the instance label to a stable name, preventing cardinality drift if ports change. This is the same issue we highlighted at the start. Here's exactly why that happened. A single read replica had slow disk I/O after a storage resize. The load balancer sent about 1% of queries to this replica. Because 99% of requests were fast, average latency never budged. P99 metrics didn't exist on any dashboard, so no alert fired. Engineers spent 45 minutes looking at green dashboards while users experienced 30-second hangs. The fix involved adding P95 and P99 latency histograms as first-class metrics, alerting on P99 thresholds, enabling distributed tracing to reveal the replica routing pattern, and implementing load balancer health checks that test actual query response time, not just TCP connectivity. Using average latency as your alert metric hides tail latency. In the incident, average was 120 ms, but P99 was 30 seconds. Always use histogram quantel for P99 and alert on that. If you don't propagate W3C trace context headers on every outbound call, traces will be broken across services. This makes it impossible to correlate a slow span with the downstream service that caused it. Never include unique per request values like user IDs as metric labels. Each unique value creates a new time series, and with millions of users, this will consume all memory and crash Prometheus. The article mentions OpenTelemetry Auto-Instrumentation, but does not note that it requires the JavaGent flag at JVM startup. Without this, no spans are created and trace context is not propagated. Ensure the agent jar is on the class path and the flag is set in the container entry point or deployment manifest. The article mentions exemplars, but does not show how to enable them. Exemplars link a metric observation to a trace ID without creating a high cardinality label. Enable exemplar storage in Prometheus with enable feature equals exemplar storage, and configure your metrics library to attach the current trace ID as an exemplar. The article advises tiered log retention, but does not emphasize that sampling should happen at the collection agent, e.g., fluented, vector, before data hits the storage backend. This prevents storage overload and reduces costs. Implement per service rate limits and drop debug logs at the agent level, not after ingestion. When your observability pipeline fails, run these checks in order. Start by verifying the metrics endpoint is reachable from inside the Prometheus pod. Then check trace headers on outbound requests. Use the Prometheus API to query raw metrics and identify cardinality explosions. Let's run through some common interview questions. Average latency 100 ms but P99 fives? What does this tell you? Heavily right-skewed distribution. Check for single slow replica, GC pauses, cold cache, or connection pool exhaustion. Explain unknown unknowns in observability. Failures you didn't anticipate. Monitoring misses them, but rich telemetry lets you ask novel questions during an incident. How to instrument an intermittently slow database query. Add histogram metric for query duration, trace the query span, and log the query parameters with trace ID. And a few frequently asked questions. What's the difference between monitoring and observability? Monitoring tells you something is broken. Observability lets you figure out why. Why is trace ID in logs important? It links a log line to the full request journey, enabling one-click root cause analysis. How do I avoid Prometheus cardinality explosion? Never use unique per request values, user IDs, order IDs as metric labels. Use exemplars instead. To wrap up, monitoring tells you when something is broken. Observability tells you why. Always correlate metrics, logs, and traces with a common trace ID. Never rely on averages, monitor P95 and P99. And watch out for cardinality explosions in Prometheus. Thanks for watching. Ready to go deeper? Up next, Prometheus and Grafana setup, then Elk stack, then application performance monitoring. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.